Good day, matric students. Today, I want us to take a dim view and apply the zebra approach to the paper that was written nationally by class of 2024, plus or minus few hours ago. Fundamentally speaking, a myriad of students were engaged in a double parking because of this particular question precisely. But I want us to look at it at least by means of a wider view and a tangible, concrete sense, just to give you guys the slightest idea of how you should have approached this particular question. 1.3, let's check. They say, consider the product 1 plus a half into 1 plus a third into 1 plus a quarter there. Okay, they say that each factor in the product is in the form of 1 plus 1 over n, where n is a positive integer, but from n is greater or equals to 2 there. Determine all the values of n for which the product will be an integer value. Please get the question for which the product will be an integer value. So I'm going to pen down what we have here. We have 1 plus a half into 1 plus a third into 1 plus a quarter. Okay, so this is possibly going to go to infinity. You don't know. All right. They say that each factor in the product is in the form of 1 plus 1 over n. That means that is going to be your last term then. Now, let's try and really simplify that first sum there. So we're going to have 1 plus a half. It's going to give you 3 over 2 into 1 plus a third is possibly going to give you guys 4 over 3, right? Think about it. Or use calculator. You get 4 over 3 into 1 plus a quarter. You get 5 over 4. And then multiply by, this is going to continue up until the last term. So the last term, let's assume that you have 1 plus 1 over n, just like that. Okay, so this is going to be the last term. So if you simplify this last term, just think about it. You are going to have 1 plus 1 over n, which will be n. So you're going to have n plus 1 if you try to simplify this one. So I can as well write this in a form of n plus 1. Think about it. So allow me to rewrite this particular portion here. Maybe let me just leave it, and then in the next part, I'll try to bring it to your attention. Let me just put it there. So now you have 3 over 2 into 4 over 3 multiplied by 5 over 4 multiplied by, this is going to continue to the last term, which is in the form of 1 plus 1 over n. But we have agreed that this part is going to be n plus 1 over n. Think about it. I want you guys to observe something here. This is the last term. Okay, it means the term before the last, which is the term that is here. That is going to be 1 plus 1 over n minus 1. You can try and simplify this, and then you get that's going to be n minus 1, all right? And then you simplify it, it's going to be n minus 1 plus 1, which is n over n minus 1. So I'm going to have here n over n minus 1. Think about it. So allow me to clear up this one and get maybe the third term before the last. Let's see what we're going to have there. So that's going to be 1 plus 1 over n minus 2. So if you simplify this, you're going to have n minus 2 into n minus 2 plus 1, which gives you n minus 1 over n plus, that should be minus 2. So it therefore tells you and me that the third term before the last, what do you guys have? You guys have n minus 1 over n minus 2. I want us to just stop here. We can get a bunch of terms in there because this is really saving a bunch of terms, all right? So now pay attention here and apply some zebra approach. Look at this 3 here. It's going to cancel this 3, okay? And then this 4 is going to cancel this 4. And then this 5 is going to cancel the term which is going to be here. It's possibly going to be 6 over 5. Now, in terms of this last term there, you clearly agree with me that the n would cancel with this n, all right? And then n minus 1 is going to cancel with n minus 1. And then n minus 2 would cancel with the n minus 2 over n minus 3. So it's going to cancel with the term which is going to be there. So you basically have a beautiful product here, you know. You basically have a product of this part here is going to give you guys 1 over 2 multiplied by the last product, which is going to be n minus 1. Okay, so therefore, the product of that given stuff there is going to be n plus 1 over 2. This is the product. Now, read the question. They say determine all the values of n for which the product will be an integer. Okay, so for what values of n will this be an integer? Now, think about it, but this integer has to be greater or equals to 2. Now, if you take 2, it won't really work there because you're going to have 2 plus 1, which is going to be 3 over 2. So if you take 3, if you substitute 3 for n here, you are going to get 4 over 2, which is going to be an integer. If you take 4 plus 1 is going to be 5 over 2. But that number is not an integer. So therefore, notice that if you take every even number from n bigger than 2, you're not going to get any integer value. So your n must be an odd number, like your 3. If you take 5, you take 7, you take 9. If you take 9, you're going to get 9 plus 1 over 2, which is going to be 10. I mean, it's going to be 5. So 5 is an integer number. So your conclusion now should be that therefore n must be an odd number for the product to have an integer value. Okay, for the product to have an integer value. Okay, so therefore now your n should be everything from 3, 5, your 7, your 9 there. This is really going, there are a bunch of them, by the way, and then that will really continue like that. This is how I'm going to answer this question. Let me know if you understand my chronological way of thinking. There might exist another way of doing it. You are more than welcome, as long as it's logical and it's mathematically correct in there. And also comment which question I must do on the TikTok. But I've received the one of finance 7.3.2. I'm gonna work it out as well for you. But by tomorrow morning, I should have posted the memo for the whole paper. I'm typing it already. So this one, it came to my attention because everyone was requesting it. And I'm going to upload it on All the Best for Paper 2. Thank you for watching.